Hello everyone, this is Dennis and you're on the Electro channel. Today we'll be reviewing this voltammeter. The voltammeter is designed to operate on alternating current and can measure current up to 100 amps. For this purpose, it comes with a coil like this. This is a current transformer. The operating voltage is from 60 to 500 volts. This type of voltammeter is usually installed in electrical panels. A large hole is made in the wall of the panel. Then the voltammeter is inserted into it and tightened at the back with a nut. At the back, there are two terminals for connecting the AC power supply and thin wires with a connector. The current transformer is connected to this connector. The current transformer contains a round metal core, and on it is a coil with a large number of turns. After installing the voltmeter in the electrical panel, the voltmeter and current transformer are easily connected using a connector. The connection diagram looks like this. These wires carry alternating current, phase, and neutral. Here I've drawn the wires in red and blue, but in reality, there's no difference where to connect the phase and neutral. One of the wires, going to the load, is fed through the current transformer. I've drawn a light bulb as the load here, but in reality the load could be anything, even a kettle, an iron, or a hairdryer. You could also power the entire house through the current transformer. The second wire is connected directly to the load. The voltammeter is also connected to the AC power supply. It can be connected with thin wires, as it draws very little current. Now let's see how accurately this voltammeter reads voltage. Now I'll compare it with my multimeter. I connected both devices to the power line. As you can see, the voltmeter slightly overestimates the voltage. Now I'll connect a low power load. This will be a 60-watt incandescent bulb. Let's see if the ammeter detects its current consumption. It should be around 250 milliamps, but as you can see, the voltmeter doesn't detect it. It shows 0. Now off camera, I've connected an electric kettle. Let's see how much current it consumes. After turning it on, it turned out to be consuming 7.7 amps. By the way, note that after turning it on, there's a voltage drop in the wires. If the wires in your house are thin or the connections are poor, then the voltage drop can be very large. Now let's compare the reading from this voltmeter with a clamp meter. I connect the blue wire, and the voltmeter shows 9 amps. The clamp meter shows the same reading, but the voltmeter's reading is lagging. Now I'll try this. I'll try passing a very high current through the current transformer. For this, I'll take a powerful transformer and try to short circuit its secondary winding. But ignore the voltmeter. It's connected to the line voltage, and I'll short circuit the secondary winding. I'll short circuit the wires. And, as you can see, the current is 90 amps. With such a high current, the wire in my hands quickly heats up. And notice that the ammeter readings don't update immediately. They're delayed by about 2 seconds. That's all for today. Like and subscribe to my channel if you haven't already. Ask questions in the comments if anything is unclear. Click the bell to stay updated on new videos. Bye everyone.